So let's look at how to rearrange a formula so that we can make a given variable the subject of a formula. Okay, so for example 1, let's look at this formula a equals 3b minus 5, and let's try to make b the subject of the formula so that b equals the other variables and constants in some new shape or form. Okay, so the way we approach these is we look at the term that contains the variable b, that's the one we want to make the subject of, and we examine what's happening to b, and what we mean by this is we look to see if b has a coefficient, if there's any number multiplied by b, or in other cases is b actually being divided by some other number. Okay, so in this case we look at the term that contains b and we see that it's been multiplied by 3. And then we also note that the term that contains b, 5 is being taken away from that. So 5 is being subtracted, so we make a note of that as well. But when we examine the term that contains b, the first thing we look to see is if it's been multiplied or divided by anything before we move on to see if anything is being added or subtracted to it. Okay? When we know these facts, we then set about designing our solution, which means that we'll actually do the opposite to what's happening in the opposite order. So the first thing we'll do is we'll add 5 to both sides of the equation, and we'll look to see if anything cancels after that. And following that then, we'll divide all terms by 3. So if you look at this, we're doing the opposite. Where 5 has been subtracted here, we're actually adding 5 here, and where b was being multiplied by 3, we're going to divide all terms by 3. So we're doing the opposite. We're dividing instead of multiplying, and we're adding instead of subtracting. And that's what we do all the time. So let's add 5 to both sides. Okay, so that means that we'll have a plus 5 equals 3b minus 5, which is what we had anyway, plus 5. We'll look to cancel, and we'll see that this minus 5 plus 5 disappears, so there's nothing, 0. So now that leaves us with a plus 5 is equal to 3b. Now we have to divide all these 3 terms, 1, 2, and 3, by 3. So we have a over 3 plus 5 over 3 equals 3b over 3. We should note that these two will cancel, so that will give us b here. And we can seek then to reduce these two fractions into a single fraction by noting the lowest common multiple of both fractions, and that's 3, and rewriting this 3 as the denominator of our new fraction. And where we can just say 3 goes into 3 once, 1 times a is a, and 3 goes into 3 once, so it's plus 1 times 5 is 5. So b is equal to a plus 5 over 3. Now we look at a second example, but this example is slightly different in that we have to do some factorizing. So let's make a the subject of the equation ab minus 3a equals 5. Well, the first thing we need to do is to factorize the a out of these two terms. Okay, so ab minus 3a is equal to 5, so a is the highest common factor to both of these terms. So we have a outside here, and we divide both terms by our highest common factor. So they'll cancel, and they'll cancel, so that can be rewritten as a times b minus 3 is equal to 5. Now we can examine what's happening to a, because it is a that we're seeking to make the subject of the formula for. So what's happening to a? Well, a is being multiplied by b minus 3. So if that's the case, we're going to divide all terms by b minus 3. So we rewrite our equation here. A times b minus 3 equals 5. So we have a times b minus 3 equals 5, and we'll divide both terms by b minus 3. They'll cancel, and that will mean that a is equal to 5 over b minus 3. And now let's look at a third example, and this example involves fractions in the formula of the equation. So make x the subject of the equation 2x minus 1/3 equals y over 3. So the solution to these, as soon as you see a fraction, is to get rid of the fractions, or as I would say, flatten the equation out, okay? So 2x minus the third equals y over 3 can be rewritten by just putting a 1 under the 2x just to balance up the equation. So if 2x over 1 minus 1/3 equals y over 3, it's just easier to work with the equations this way. Then we look to see the lowest common multiple of the three terms of 1, 3 and 3, and that is 3. So we'll multiply all terms by 3, or indeed 3 over 1. Okay, so we have 3 over 1 times 2x over 1 minus 3 over 1 times the third equals 3 over 1 times y over 3. So we look to cancel, nothing cancels here, 3 by 2x is 6x, 3 cancels once, goes near once, so we have 1, and 3 goes itself there once, and there once, they'll cancel, and we have y. 1 by y is y. Now that the equation has been flattened to look like 6x minus 1 equals y, we can now examine what's happening to that term that contains the x. Well, the first thing is that the x is being multiplied by 6, and the second thing is that that term that contains x minus 1, or 1 has been subtracted from it. So we'll do the opposite in our solution. We'll add 1 to both sides, and then we'll divide all terms by 6 once we've looked to cancel in between the two steps. So we rewrite 6x minus 1 equals y as 6x minus 1 plus the 1 equals y plus the 1. These two will cancel, so 6x will be equal to y plus 1. We now need to divide all terms, okay, all terms by 6. So we'll have 6x over 6 is equal to y over 6 plus 1 over 6. So x is equal to y over 6 plus 1 over 6. And as we've seen in the earlier example, these two fractions can be reduced to the single fraction, that is, x is equal to y plus 1 all over 6. So let's look at the last example now. Make R the subject of the formula P equals QR divided by Q minus R. Okay, well, the first thing to do with this is to get rid of the fraction first, flatten the equation. Okay, so if P equals QR over Q minus R, then we'll just balance it up first by just putting a 1 under the P. We'll then look to see what the lowest common multiple is of 1 and Q minus R, and that is Q minus R. So we'll multiply both, all terms, by Q minus R, or Q minus R over 1. So Q minus R over 1 times P over 1 on this side, and Q minus R over 1 times QR over Q minus R on the other side. And nothing really cancels here, so we'll end up with Q minus R times P here. But here, this will cancel with that there, so we'll have QR on this side. Just 1 by QR is QR. So we have this new flattened equation, QP minus RP equals QR. And this is the equation that we're going to work with to try and make R the subject of. Okay, and how will we do that? Well, the first thing to do is to gather the terms containing R. That's this term and this term here. So we'll rewrite this as QP equals this term plus this term which comes over the bridge. Then we'll factorize R out of these two terms because R is the highest common factor, so that's the same as saying R into QR over R plus RP over R. And the R's will cancel, so we'll end up with R times Q plus P. We can then look at, we have this equation now that we can look at what's happening to R, and we can see that R has been multiplied by Q plus P. So we'll divide all terms by Q plus P. So if we rewrite our equation here, we've QP equals R times Q plus P. We'll divide QP by Q plus P, and we'll divide R times Q plus P by Q plus P. And we can see then that Q plus P will cancel with Q plus P on this side. So we're left with R is equal to QP over Q plus P.